In this short demo, we'll look at a simple biosurveillance application built with Vantiq, a platform to build real-time intelligence systems. Vantiq accelerates the development of these applications by providing tools to build real-time analysis of incoming data, connectivity to third-party platforms, AI and generative AI integration with specialized patterns for creating complex agentic systems. Client building tools also allow rapid visualization and interaction with the system. Let's look at the various parts of our application and the back-end real-time logic that supports them. On the bottom left, you see the results of an agentic system that monitors social media sites for current outbreaks in the defined area. The flow automatically starts collecting information from APIs and websites. And this flow starts off the process, and our agent reads the content and produces an object outlining potential areas of interest. Another agent aligns the ICD-10-CM codes, which is a standardized system used to classify and code diagnoses, symptoms, and procedures for medical billing and statistical reporting in the US, but of course, any system could be used. They are then automatically placed on a watch list of interest. As you can see here in the UI, as we switch to the ICD-10 page, and filter the content based on those clusters of interest. This is where things get interesting. In our demo, each hospital participates by sharing the real-time codes for diseases identified in the hospital. Each hospital has their own instance of the Vantiq runtime. The Vantiq system deploys a custom version of the application to each one of the participating hospitals. Some of the hospitals participate by integrating into their ADT system, a system that keeps track of admissions, discharges, and transfers. The ADT messages include ICD-10 codes and are easily parsed by the application. And so Vantiq deploys to the hospitals a version of the application that integrates with it. Some of the hospitals participate only by sharing doctor's notes. They get a different version of the application that uses a private LLM to parse the notes the doctor enters about the patient. The agent looks at the note to derive the ICD-10 code, parses it, and forwards it to the central system. The central system never sees the hospital's private data and only receives the name of the hospital from which it came and the related code. This allows for a federated and distributed runtime to monitor for potential disease outbreaks, sending data in one direction, ensuring that hospital data stays private and only the statistics are shared. In our web application, we see a real-time chart showing us the number of each disease across all hospitals on a per-day basis. The map shows for the selected time range the number of occurrences of the disease. We see in the line chart a positive trend for code A90, which is dengue fever. We can filter to see just those cases. This also updates the map to cluster the disease counts for only that code, and so we're able to see where the disease counts are greatest and in which area. This will also help us make sure that we have the appropriate supplies. For example, in each hospital, we can see the number of available beds and ICU beds. We can even drill down to see more details or information about available medications and equipment that is shared with our system. We will want to be notified when a certain number of cases crosses on a given day, and so we can go to the Alert Threshold tabs and edit the rule for when we want to be alerted. Now that we've adjusted our threshold, let's see what happens when a few more cases of dengue fever are reported. As each case comes in, we see the dashboard is updated. But Vantiq gives us the ability to not have to watch the dashboard. It can alert us when there's something of interest to see. When the threshold is crossed, the alert is sent. Here, you see a simple notification in the interface, but it can also send push notifications to mobile phones, emails, and update other systems that require the data. The last thing we'll look at in this demo is our agent, Emma. Emma is the Epidemic Monitoring and Mitigation Assistant. Emma is responsible for watching the social media sites, APIs of interest, to provide our overall watch list. Emma also has a conversational interface and has access to the shared hospital information, statistics, and more. Emma can be queried with natural language. For example, I might ask, how many cases of measles over the last 30 days? Emma gives a breakdown of each hospital and the totals of the count. Or perhaps I say something like, what hospitals have resources to support an outbreak of dengue fever? Emma determines, based on resource availability, which hospitals are best suited to handle the new cases. This is just one kind of application that can be built on the Vantiq platform. Applications that require performance, distribution and federation, security, and orchestration of streaming data, other systems, AI, and generative AI. Imagine what you could build.